Hi, today we're solving problem 37. The number 3797 has an interesting property. Being prime itself, it is possible to continuously remove digits from left to right and remain prime at each stage. So 3797 is prime, 797 is prime, 97 is prime, and so is 7. Similarly, we can work from right to left. So here we have the same number starting, but now we're going to remove the rightmost digit. So 379, 37, and 3. Find the sum of the only 11 primes that are both truncatable from left to right and right to left. And they have a note that 2, 3, 5, and 7 are not considered. In this problem, the solution is going to be pretty simple. We're going to implement checks for checking if the number is truncatable from the left and if it's truncatable from the right. And then we're just going to iterate over all prime numbers that we know and filter the ones that are both truncatable from left and from the right. So I'm going to go over and switch over to IntelliJ. For this problem, to calculate all of the prime numbers to check, we're going to use the sieve of Eratosthenes, which we saw in problem number 35. And we're also going to use the number of digits in a number from another problem, and so I've copied these both into the util object. One thing you'll notice is they haven't given us an upper bound for what the highest of these 11 primes might be. So what I'm going to do is I'm just going to pick a random large number, 1,000,000, and we'll count to make sure that there are 11 primes. So I'm going to do val primes is equal to sieve, and then I'm going to have to import everything from util. And sieve takes an upper bound, which is going to be 1,000,000. Now we can implement the checks from checking if the prefixes of the number are prime and if the suffixes of the number are prime. So first we can do def prefixes prime. It's going to take a number of type int. When we want to calculate the prefixes of the number, it's pretty simple. All we need to do at each step of an iterative loop is divide the number by 10, and that gives us all of the digits except for the rightmost digit, which gives us the next prefix. So we're going to implement this as a tail-recursive method. I'm going to create a def helper inside of this method, which is going to have current of type int, and we're going to return a boolean, which is does it work. Now the first thing is we need a termination case. That's going to be when cur is 0, and we're going to return true. But if cur is not 0, then the first thing we have to do is check that cur is prime. So I'm going to do, and to do that, since I already have a set of all the prime numbers, I can just do primes dot contains cur. So we want to make sure first that all of the prime numbers contains the current number, and we need to make sure that the prefixes are prime of num divided by 10. So this is where we calculate the next prefix. And not prefix is prime, actually we need helper, because this is going to be our recursion, so that when you're using prefixes prime, you don't have to see the part of it which is recursive. Now all we do is call a helper with num, and we get a boolean, which is if it is prime. And all of its prefixes are prime as well. Now what we need to do is calculate if the suffixes are all prime. Suffixes prime given a number of type int. Here again, we're going to have a tail recursive method, so I'm just going to kind of copy that part. Helper takes cur of type int. It's going to give us a boolean. Again, we're going to have the same termination case. If the current number is 0, then it's true. Otherwise, and when calculating the suffixes of the number, it's going to be a little more complicated, but not too much more. What we want to do now is take the number and knock out the first digit, the digit all the way to the left. And the way we can do that is taking the number and doing mod, and we're going to take the highest power of 10 less than that number, and that'll just knock out that digit. Now, how do we calculate that highest power of 10 less than the number? What we're going to do is calculate the number of digits in the current number, which is why we had that method in util. And then knowing the number of digits, we can just do 10 raised to the number of digits minus 1, and that gives us that power. So we're going to do first prime dot contains the current number, and helper, what I'm going to do is num mod, and I'm going to do math.pow to calculate the power. It's going to be 10 raised to num of digits in cur minus 1. And I need to do math.pow to int because we want to work with integers here. And I'm going to call helper with num here. So now we have a check if the prefixes are prime and the suffixes are prime. For a quick check to make sure this is working, we can do prefixes prime of 3797 and suffixes prime of 3797. I can run this. And looks like we got into a little bit too much of recursion here. So first I'm going to start with prefixes prime. Let's make sure this is working. Aha! I already see what we messed up. I'm doing num here. I need to do cur. Okay, now we can run. So prefixes are prime. Now I need to check if suffixes are prime. And this should be true. So it's true. So we know that these are working. Now what we want to do is we want to iterate through all of the primes that we calculated. So primes. And one thing we want to make sure we do is knock out 2, 3, 5, and 7, because we don't want to check those because they're not considered to be truncatable primes. So primes minus 2, minus 3, minus 5, minus 7. So what I'm doing here is I'm using the minus method on sets, which returns me a new set with that element removed. And so I can just do minus 2, minus 3, minus 5, minus 7, which is removing all of these numbers from primes. And now I just filter the numbers such that the prefixes are prime of the number and the suffixes are prime of the number. And we need to find the sum, but first let's just do val truncatable, or let's just do found. It's a lot shorter. So these are the ones that we find that match what we're looking for. I'm going to just println found, or maybe found.size, so that we make sure that we have the 11. So yes, we do have the 11 that we're looking for. So we know that our upper bound is high enough. Now we need the sum. So I just do found.sum. And we get our answer, 748317. So that's it for problem number 37. I'll see you next time when we solve problem 38.